Dear students, those who are in online lab, those who are taking up online lab, I think they are supposed to do the Proetus experiment because you cannot do any hardware experiment at your end. But still, I welcome you all if you are in Dubai, if you are able to come to campus. So please come and do the hardware experiments, other two hardware experiments where you do the experiment, you see that physical components. You will connect a motor, stepper motor to a processor and see how it works. And also you just do other hardware experiments with the physical hardware thing. Those who are not able to come, so stuck in India or Abu Dhabi somewhere, you can do this lab 9 through Proetus once again. And this lab 9 is something to do with the memory interfacing and display that content of the memory on the 7 segment LED. Here we are going to interface memory through programmable peripheral controller 8255, which you have used in previous two experiment, that is in lab 7 and lab 8, and display the content of the memory in a 7 segment LED. Here you are going to use a ROM chip, and data to the ROM chip is supplied through a notepad, a text file. Okay, that in due course you can see how exactly to do that. Okay, so as usual, the block diagram, or how we are going to interface a memory to 8086 through 8255 and then display the content on the 7 segment display. Okay, now see what exactly we are going to do here is that the connection 8086 and buffer and 8255 remain same. These things remain same, right? So what we do, we send the data address. Okay, we just send the address from which the data has to be read through port E. Okay, and whenever the address is supplied to this ROM A, okay, and the read signal is also used to read the data, okay, the ROM will put the data corresponding to that address, okay, in the data bus, which is connected to the display. That is what it is going to do. Right? So the address is generated by this port A, and as soon as the ROM gets the address, and corresponding address is generated here. And in the program, you are going to generate certain addresses from 0001 like that till FF it will be generated. And you can see that the corresponding data, which is actually stored in the Excel file, in the notepad file, okay, will be displayed here on the memory content. That is in the display. Okay, so this is what you're going to see. The real circuit diagram you can see here. See the circuit diagram. Now, see, this connection is same. You can see this 8086 and all this same as one you already done it. And what other things you're going to do is, the address is generated through 8255 and these addresses are displayed here. The last two digit of the address is displayed here. We're using only that a small part of the address. We're not using all the addresses. Now this is your memory chip. It's a memory chip. Okay, and this memory chip is going to give the data, okay, as soon as you generate that particular address, right? So once it gives out the data corresponding to that address, that is given to this 7 segment LED. Okay, and this 7 segment LED will actually generate that data. Okay, this is what it does, right? Because data which you are going to put is only which we are going to see here is only 0 to F. That's why we are using only four bits of this. It's a very simple method of interfacing a ROM and a 7 segment LED. Right? You can see here we are using only 4 line. Why we are using only 4 line? Because we are going to display only 0 to F, which requires only 4 bits. And this 7 segment display is, it's a different from one you used earlier. this is actually having a decoder inside it. Okay, a decoder inside it. That's why input is only 4 bit for this. Here also input 4 bit. Here also input 4 bit. This chip itself has a 7 segment decoder into that. Right. Okay. So now this you can just do the connection as you have done earlier. I think at this position you have already practiced do the connections. Okay. So this is the connection diagram and the program here. And this program you will really you will understand whenever you cover 8255. 8255 is a programmable peripheral interface which can be programmed using a program status word. So how to use those program status word, what is a port, and all those things you will definitely study in 8255, which will be dealt maybe in next week. Okay, as usual, you can start with the double clicking on the icon and go for a new project. And you all know this step: your project name, select proper things, okay, and uh, select 8086. This step also you know. And then what you will get is a schematic capture menu and a source code. In schematic capture menu, so what you have to do is you have to draw the entire circuit diagram which is given in the manual, and what are the components to be used, everything given here. You can add all the components which is to be required, and then you draw the circuit diagram. So once you draw the circuit diagram, then type in the program. Don't try to do copy and paste. Try to type in the program, whatever is given in the manual. Then build the project. See that it is successful. After that, you have a small work to do. What is that small work to do? See, here you have to put the data corresponding to. You have to put the data corresponding to the value which you are going to display. Right. So now each digit is going to display 0 to FF. This is also going to 0 to FF. So totally it is going to display digits. Okay. Now you open a new notepad file. Okay. In that notepad file, okay, you can just put the values. Here you can see it is AA62 02 12 0A 0B FF 2F. All these are data, right? And one thing remember, this AA corresponding to the data corresponding to address 00, 02 corresponding to address 01. Like that, you have all this data corresponding to that continuous address, like 01, 02, 03, 04, 05, 06, 07, 08, 09, A, B, C, D, like that. Okay, so this is the file you have to generate, okay, in the notepad, and save it as anything, something like, but extension should be .bin, my data.bin. Okay, so open a notepad and insert a number to be stored in the ROM and save it as a my data.bin. Okay, hope you understood this. Okay, now once you are done with that, okay, so that's what I have explained you, that this data corresponding to 00 address 00 and 02, this is corresponding to address 01, and this is corresponding to it, and so on. Okay. Now what you do, will you add this data to the ROM? Okay, so you are going to choose ROM IC 27512. How you are going to add this data? Okay, double click on the IC. Okay, double click on the IC, you get this menu. Now image file, go to image file. Can you open this? See, there is a folder open icon there. Okay, open that folder, okay, and select that mydata.bin wherever you have stored it. Okay, after that, one small thing you have to do, that is, okay, so once you put this entire thing in the file here, in the image file, see, once you open this and select that bin file, this entire information will appear there. Okay. And see, you will get only till this point, till mydata.bin. One thing you have to add, one small thing you have to add is, you give comma as ASCH hex. Okay, it is this ASCHEX you have to add as an addition to that. Okay, understood this? Okay, so now once you do this, okay, you save this, press OK, press OK. After that, as usual, you run the simulation. When you run the simulation, you can see this particular 7 segment AD will display the address. This will display the value. Now you can open that notepad file which you have saved and check the data whether it is displaying as per the uh, data which you have stored in the notepad. If it is displaying, then your execution is correct. And also you change the data, okay, once again, okay, and then see it is displaying whatever data changed. This is what you're going to do in this experiment. Okay, so it is same as the circuit diagram and the program writing. Everything is similar to the one you have already done earlier, so you can easily do it without any instructions in the laboratory. Go through this video again and again, and you can do this. Okay, this is what the circuit you have to draw it properly. And I told you, double click on this, and if you see this here, if you click on this, you can add that bin file which you already created, and you can see that till here, till my data.bin will appear. After that, manually you have to add these ASCHEX in that. Okay, and then save it. Don't touch anything here, just save it. That's all. Right? So once you did that, you can keep your notepad file open here just to check the data whether the same data is displayed or not. Right? Now just go to your debug, then you check your program first. I think once you're done with the program, and if it shows executed properly, you can rebuild it, build the project once again. It shows completed successfully, and come to the schematic capture, go to debug, and then run simulation. Okay, you can see that whether it is going to display. Fifth one is FF. See here, fifth one is FF. You can see that 101112, it continues like that. All other addresses are 0 because I not added in this. In this Excel file, if you add all the data, it will go till FF. It will show that entire data in this. 01 is AA. You can see I have put AA here. Okay. Then 02, then 3F, then 4F, then 5F, then 6F, then 7F, 2, 3, 3, 4, and 4, 5. And other data is not there, but it is showing as a 0, 0, 0, 0 here. If you put the data here, you can see, you can check it. You can add some data, and once again simulate, you will get the data what is stored in this. This is what you have to do in this experiment. So do this and enjoy this experiment.